Hello there, and then welcome to a brand new video. This is Happy Beyond Numbers, where we learn maths the easy way. Now, in this lesson, we are looking at a gradient, or in other words, the slope of a line. And by the end of this lesson, you should be able to understand what gradient of a line means, then how to calculate the gradient when you are given 2 points on the number plane. And also use gradients to describe the steepness and direction of a line. So without much I say, let's quickly look into it. So when we talk of gradients, we simply mean how steep is a line. You get it? How steep is a line? So let's say I have this line over here. How steep is it? The line can also be this way. You see, how steep are all these lines I am drawing over here? Now you realize that if this line over here was supposed to be a road, you would need to paddle or apply more strength to be able to climb up. But if you have a road compared to this one, it is a little bit towards the ground, you see, hence you are going to need less, you see. But what if the road has now become straight like this? You can easily walk on it, you see. So gradient simply tells us how steep a line is. So there are 4 values of gradients we need to understand and then know what they are. You get it? Then after which we'll now come to the formulas we use to solve for gradient. So let's look at the interpretation of gradient. So when we say a line has a positive gradient, then it simply means that the line slopes upward. You see, so a line as this will have a positive gradient. It doesn't matter. For its magnitude, it will depend on what? Its inclination. But for the signs, it being positive simply means what? It slopes from what? Upwards. That is from the left-hand side to the right-hand side. You get it? Now, if a line slopes downwards, that is it slopes downwards from left to right, something like this, then it's going to have a negative gradient. So let's take note. A line as this has a negative gradient, whilst a line as this has a what? A positive gradient. Now, on the other hand, if you have a horizontal line has a 0 gradient. You see, it has a 0 gradient. And finally, a vertical line, on the other hand, has an undefined gradient. So now that we know these gradients, or what a line represents in terms of gradient, how do we solve for gradient? Solving for gradient, if you have 2 points, such that your first point is x1, y1, and then your next point is what? X2, y2. So for any 2 points at a time, then the gradient, normally represented as m, is the change in the values of the y. So change in your y value all over the change in what? X value. And what do we mean by change in y value? It simply means find the difference between the y values. That is y2 minus y1 all over what? Your x2 minus x1. You can also write it as y1 minus y2 all over x1 minus x2. The most important thing here is you keep your order. So if you are using y1 minus y2, then use x1 minus x2. And if you are using y2 minus y1, then for the denominator, also use what? X2 minus x1. With this, you'll be able to what? Solve for any gradient of a line, provided you have 2 points on the line. So let's look at some examples here. So for our first question here, we have to find the gradient of the line joining the point A, which has coordinates 2, 3, and then b, which has coordinate what? 6, 11. So our solution. Now we know if we are representing gradient with m, then the gradient of a line is given as what? y2. So our y2 minus y1 all over what? Your x2 minus your x1. You see? So if this is your formula, then all this means is at any point in time, you need to be able to tell what your x1, y1, x2, and then y2 are. So for the given point where you have your a being 2, 3, and then your b being what? Your 6, 11. Then we are going to write that our x1, y1 is going to be the set that we have in A, and then your x2, y2 is going to be that of B. Hence, substituting into our gradient formula, we are going to get our m, which is equal to y2, that is 11, minus y1, which is 3, all over x2, which is 6, then minus x1, which is what? 2. Simplifying further, we have m being equal to 8 over 4. And 8 over 4 gives us what? A 2. So we say, therefore, the gradient of the line joining this point is what? 2. And if it is 2, you remember our interpretation. So it is a line that moves from the left to the right upwards. It has a positive gradient. You see, there's a line that moves from left to right upwards. Okay, let's look at some few more examples. So for this second question here, it says you have to calculate the gradient of the line connecting P, which has coordinate -4, 7, and then Q, which has coordinate what? 2 and then 1. So our solution, the formula still remains the same. And the most important thing here is you identifying what your x1 and then y1 is, and what your x2 and then y2 is. Hence for our p, which is what? -4, 7. We are going to let that be our x1 and then y1. And then for our k, which is 2, 1, we are going to let that be our x2 and then y2. You see? So now substituting for our m, we are going to get our m, which is now equal to the y values. We said y2. So that is a 1 minus y1, which is 7, all over your 2. So you have your 2, then minus your -4. That is your x value over here. Simplifying further, you have 1 minus 7, which gives us a -6, all over. Remember, applying integers here, it means you are going to get what? A 2 plus 4, because of these two negatives you have over here. You see, so you have 2 plus 4, and 2 plus 4 then gives us a 6. You see, so on that note, we are going to get a -6 divided by -6, which then gives us what? A -1. So our gradient is a -1. So its line will be something like this. It moves from the right to the from the left to the right downwards. You get it? Okay. Now, as I said earlier on, we said our gradient, apart from the formula we had written there, can also be written as what? y1 minus y2 all over x1 minus x2. You see, so I said that if you are consistent with your order, then it is well. But if you go and then switch the orders, you make the numerator y1, y2, and then you come and then make the denominator x2, y1, you're going to be wrong. So with this same set of values, let's try and then see if you are going to get the same answer. Okay, so with the same set of values, I'm going to copy and then paste that here. Hence, substituting for our gradient, we are going to get our m being equal to y1. So y1 this time around is our 7. So 7 minus your y2, which is 1 over here, all over x1, which is -4, then minus your 2. You see, so evaluating that, we are then going to get a 7 minus 1, which gives us a 6, all over our -4 minus 2 gives us a -6. So we can say our m then is equal to -1. That is 6 over -1, giving us -1, which is the same as what we had over here. So be consistent with your formula. I would like to solve more examples, but as you can see, these formulas are very, very basic, and then all you need to do is to master how to substitute your values into it and then work your integers. So I'll leave some exercises so you try on your own just to test your understanding. So here you have some questions you can try on your own. And as usual, this is Hub Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel, you can always choose to subscribe so that anytime I release any lesson, you can always come back to learn with us. If there's any issue of concern, you can also let me know at the comment section and I'll address that for you. Have Beyond Numbers, learning maths the easy way. Have a blessed day. Bye. And then see you in our next lesson where we look at the equation of a line. Stay safe.